Thanks a lot, Bill. So here we have just an introduction to what's going on in this project. It's great to see a number of familiar faces in the room from the last time we ran this event. It's great to see a lot of new faces. We wanted to provide a quick overview of what the project is, what we've been doing, and also then what Google is interested in. But what I really hope to hear over the next day and a half is not just you responding to the things that I'm talking about up here, but what do you see as being the future for OpenXLA? So one of the biggest values of this is an opportunity for us to hear from the community and together figure out where we're going. So this is a quick overview of what we're trying to achieve with the OpenXLA project. So we're looking to support all ML frameworks that are out there with a standard ML software stack that supports all hardware backends as much as possible. So this is unchanged. We've been going in this direction for the last 18 months to 2 years. We had our first summit 6 months ago, but we've been running community meetings longer than that as well. Nothing has changed here. We see that there isn't another ecosystem of this size out there that provides the comprehensiveness that we have. And we're really looking for, with all of you, to figure out how to actually enable this to support any ML use cases that you have. We're covering a wide variety of audiences here. If you're an ML developer, our particular goal is to make sure that the hardware ecosystem works for you at high performance wherever you are. I think today people often have the experience of the most supported hardware works well, but as soon as you're doing something outside of usual, you don't have that same level of support. The second and the community that started this whole piece was the hardware and software innovators, of which Google, we feel we're part of this community. So we're looking at building the standard ML software stack that everybody can contribute to. We don't expect that to be one unified thing. So if you look within OpenXLA today, we actually have multiple pieces of technology, but together we'd like to bring this into as much of this being shared as possible. And then, of course, we have the last benefit as you look at this room and those we have online, that this is a community where people can come together and talk about these things. And as I mentioned, shape this direction and bring to it what you're actually looking for. Something exciting going on here. Let me pause for a second while everybody pulls out their phones.
Wow, because of your speech, things are okay.
Let's proceed and see what happens. If anybody feels like that they should take action, obviously, please feel free. I wouldn't like to dissuade anybody from doing that. Moving along. So these are the major things that have changed since our last developer summit. The first one is, and we've talked about this in the community, we have an updated XLA GPU architecture. You'll hear me in this keynote and other places talk about XLA GPU. I want to emphasize this is technology that we're driving heavily, but it's not the only thing which is present in the OpenXLA community here. So we'll hear about other approaches to compilers during this day. We have seen an enormous demand increase for large-scale training and high-performance inference. And out of that, we made some significant changes to simplify getting to great performance rapidly with an XLA GPU. So those are changes that we'll talk a little bit more about today. Second one is a big focus on PyTorch. So in particular, we have an ecosystem connected to OpenXLA called PyTorch XLA. We have two areas that we've been focusing on. First is getting great performance on some of the generative AI workloads like Llama, Diffusion, and the Falcon architectures. And secondly, as we all know, and was launched about a year ago, PyTorch now has a standard compiler integration point in Torch Dynamo, and that we've brought our PyTorch XLA support to align with that. And you'll hear a lot more, but it is a real goal to make sure that OpenXLA supports PyTorch well natively through its standard APIs, rather than trying to do something different. The last one is the improved developer experience. So OpenXLA is now a standalone repository and is separated out from all the other infrastructure that Google's previously created. We do see that for those who are making changes, for example, with an XLA GPU, we have a much simpler path to go test and then get PRs accepted. And that's something that we're very happy to see and we feel is absolutely required for a community project. Again, more to come in future. This is where we see the focuses that we have for the next sort of year to 18 months, something like this. First is great performance on PyTorch. So we feel like we already know fairly well how to get great performance on the frameworks that Google is producing, JAX and TensorFlow. We think that this is an area that we really need to focus on to make sure that the most broadly used research ecosystem, PyTorch, is very well supported. Second, although we support all backends, GPUs still are the most commonly used accelerator out there. And it's very important with the demands right now for generative AI that we have the absolute best performance on GPUs. And then the third is making sure that we're strengthening the ecosystem. Within this, we have breakouts today that talk about PGRT and stable HLO. And we also have a lot of discussion about how to support CPUs, for example, which is something we haven't talked about so much at our last conference. So making sure that we really are covering the entire ecosystem and not just looking at a subset of it. We'll hear a lot about PyTorch in the next day and a half, as I mentioned. Super important framework, obviously. As just described, running very large-scale workloads there is one of our key focus areas. But a second one also is making sure that we serve models across all environments. So with stable HLO in particular, we have great support on the server ecosystem, both for training and inference. But we would like to see that actually extends out well to the mobile environment too. So that's been a focus of the team. And then, as I've already described, portability and making sure that, in particular, when you are using PyTorch or indeed other frameworks, that it's really seamless to move from one platform to another. Some folks may know here that JAX has a strength as a platform that you can take basically identical code and port it between architectures with fairly minimal friction. And we'd love to bring that same thing to PyTorch as well. State-of-the-art GPU performance. Obviously, we care most with the short-term focus about the highest possible performance for Gen AI workloads. But I do want to say it's not all about that. So a compiler that works well needs to support a broad range of workloads and needs to do it without suffering major changes in performance when you make a small change to the model architecture or a small change to the underlying hardware target configuration with fewer or more accelerators, for example. That's super important. Here, we're not going to succeed without partnership. It's great to see hardware partners in the room. And we do see that the open source and open governance nature of OpenXLA is going to be a key factor to enabling other people to deliver their best performance through accelerators. The second approach we're taking here is just to make sure that we're really thinking about the easiest way to support performance. So in other words, rather than stepping back and trying to create some long-term strategies which over many years are going to deliver performance with big bets, we actually see with Gen AI, we can actually deliver a lot by taking really pragmatic approaches. So that includes, for example, OpenAI Triton, which has been a very popular kernel acceleration methodology that's been out there. And that's something we've integrated, for example, into XLA GPU and are using. We love to see that approach. So we're also part of other communities and we'll leverage whatever the best in class is under the hood to deliver great performance on GPUs. And the last one, again, comes across in many areas. We have a lot of expertise at Google on delivering a great performance on large-scale training and inference workloads. And we'd love to bring that from our experience with large-scale TPU workloads into the GPU community and are doing that right now. So as Bill already described, it's great to see so many people here in the room and online as well. It's also great to see people represented from a whole variety of areas. So, we have over 30 companies here. We have a large number of AI startups. We have all the major hyperscalers, the infrastructure providers, and we have the accelerator providers as well. I'm really excited to see this. I'm very happy that you've joined us here today, and this really actually bodes well for me for the future of the OpenXLA community. So thank you so much for coming and showing up. And with that, just a last pitch before we move on, that please do engage with the community where you can. We have a GitHub here where we have all the main code that's there. We have mailing lists available. Please join those. Similarly, chats on Discord, and we have monthly community meetings as well. So thank you so much.